connected in the feedback path of the op-amp and resistor in the input path, then the op-amp will be connected in the form of an integrator. So the connection of integrator is simply opposite that of differentiator. So in the Tinkercad also it is very easy. Once you connect on the as a differentiator, you simply need to swap the components. You will swap the components. You will connect the capacitor in the feedback path and resistor in the input path. This differentiator will convert to integrator. So for a op-amp as a differentiator, capacitor is connected in the input path and resistor in the feedback path, and the non-inverting input is grounded. Now when you do this, the Kirchhoff voltage law, when you apply KVL in the circuit, in the theory you will apply, you will do the current analysis and apply Kirchhoff's voltage law, KVL and KCL in this circuit. You will find that after derivation, the output equation V out from this circuit connection, you will get the output as minus RC into d by dt of V in. So the output of the circuit is expressed as V out is equal to minus of RC d by dt of V in, means the you can see the output becomes the differentiation of inputs. So how we are getting this equation? This equation you will get when you apply Kirchhoff's voltage law to this circuit. So when Kirchhoff, when all the current path is you will input the current and all the KVL and KCL, you will apply Kirchhoff's voltage law, Kirchhoff's current law. When they are applied here for the analysis, you will find that the V out equation comes out to be minus of RC d by dt of V in, showing that the output of this circuit becomes the differentiation of the input. And why there is minus here? Why minus comes here in the output? Because you have learned in the previous experiment that when the inverting input is, when the input is applied to the inverting terminal, you can see input is being applied to the inverting terminal of the op-amp. Non-inverting is grounded. Input has been applied to the inverting input. So therefore the output will be the inversion of the input. So therefore you will get a minus here. So here therefore you are getting a minus RC d by dt of V. And what is this? This is a differentiator, and where you are getting the output, which is differentiation of input. V out becomes minus of RC d by dt of VIT. This equation you will get when you apply the Kirchhoff's voltage law in this circuit. That those details you will do in the theory. So this is a differentiator. Now in continuation with this, so we have now understood that when a capacitor is connected with the input path and the resistor in the feedback path, and then the non-inverting input is grounded, op-amp is connected as a differentiator. The output of this differentiator will be the differentiation of the input. The output is equal to minus of RC d by dt of VIT. Now in that context, I'm just sharing the waveforms also. That means if we just a minute, I'll just show you something here. Let me share something else. Okay, are you able to see the screen? This input signal, output signal?
Yes, ma'am.
So why I am showing this? Now what is this diagram showing? That through a differentiator, just now we have seen the differentiator circuit, op-amp as a differentiator. So now we know that the output of the differentiator is the differentiation of input. So when a square wave is applied to the as an input to the differentiator, you will get a spike as a output. So the input signal is a square wave to a differentiator, output signal is a spike. When a triangular wave is applied to the differentiator, you will get a rectangular wave or a square wave. This is basically a square wave. So what is the difference between square wave and rectangular wave? The square wave, the off time and on time both are same in a square wave. In a rectangular wave, the off time and on time are different. That means off time means the lower cycle, and that means a negative cycle here, and on time means the positive cycle. In this case, off time means the off state and on time means the on state. So the difference between square wave and rectangular wave is that the for a square wave on time and off time both will be same. For rectangular wave on time off time are different. So here in this picture, whatever this rectangular they are showing, I think this is incorrect. This it should be a square wave. So therefore, you have to remember when a square wave is inputted to a differentiator, you will get a spike out of a differentiator. When a triangular wave is inputted to a differentiator, you will get a square wave as an output from the differentiator. When a sine is applied to a differentiator, you will get a cos out of a differentiator. We all know that differentiation of cosine is cos. D by dt of sine is cos. So when a sine wave like this is applied to a differentiator, you will see a cos out of it. V out will be a cos. When a triangular wave is applied to a differentiator, you get a square. When a square is applied to the differentiator, you get a spike. So such kind of observations also you will make in the Tinkercad when you perform the experiment. Let me share the other, the same. Okay. So similarly, you have the integrator here. Just now I've told you integrator. In the integrator, just opposite connections you have to do. Here you can see resistor is in the input path, whereas capacitor is in the feedback path. In the differentiator, capacitor was in the input path, resistor was in the feedback path. So during the connections in the Tinkercad, also you simply have to swap the connections and you will get the perform both the experiments. So what is an integrator doing? Integrator will be giving the integration of the input, and just like you have for a differentiator, you have an expression V out is equal to minus RC d by dt of V in. As I told you, this expression you will get when you apply the Kirchhoff's voltage law into the circuit. You will get this expression and you will find that the output becomes minus of RC d by dt of V in. Similarly, when you apply Kirchhoff's current law and voltage law to the integrator circuit, when all this current analysis you will do inside the circuit, you will find that again you can observe the input is being applied to the inverting input. Non-inverting input is grounded. So since the input is applied to the inverting input, the output will be the inversion of input. So here also in case of integrator also you can see you have a minus here. V out is minus of integration V in by RC into dt. That means 1 by RC integration V in dt. That is the output. V out becomes minus integration, that means minus 1 by RC because RC is a constant. So minus 1 by RC integration V in dt. That will become the output equation of the integrator, just like the differentiator. So here you can see given for a here it is already written, given a triangular wave, if you apply triangular wave to differentiator, it will give a square wave. Similarly, if you apply square wave to the integrator, it will give a triangular wave. So whatever output you have just now seen in the just now I shown you three waveforms, that if you apply your square wave to a differentiator, when a square wave is applied to a differentiator, you will get spikes. When a triangular wave is applied to a differentiator, you will get a square. And when a sine is applied to a differentiator, you will get a cos. Then opposite will happen in the integrator. Whatever waveforms you are seeing in differentiator, opposite waveforms you will see when they are integrator. So these two circuits today you will design in the Tinkercad and check whether the appropriate waveform you are getting or not for the differentiator and integrator. And so rest of the things, sir and ma'am will guide you. Rebati ma'am is there and Chinmay sir is there. They will guide you how to perform this experiment. Is it clear? Any doubt to anybody for today's experiment?
Ma'am. Ma'am. No, ma'am, no doubt.
Is there any doubt? Is it clear? Should I ask sir to continue with the
Yes,
Tinkercad?
ma'am. Yes, ma'am.
Okay. Chinmay sir, रेवती मैम.
Yes, ma'am. Yes.
हाँ ठीक है, कंटिन्यू कर लीजिए.
Sure. So this circuit has to be implemented for differentiator, and this is for integrator. Values are given in the manual. Okay. So this is the observation table. I have already designed the integrated circuit. There is a little change in capacitance value and resistance value. You can note it down. Okay. You can see this power supply is positive. Sorry, AC supply positive is connected to capacitor. This capacitance value in the manual it is 0.01. I have taken zero point 0.1 microfarad. Okay. Then next end of the capacitor is connected with pin number 3, and again a connection is there from pin number 3 to, you can directly take it from here also. Okay, pin number 3 to this resistor. Its value is 200 kilo ohm. Okay, it is connected with the output. Okay, and here pin number 4 is connected with positive 12 volt supply. This is ground, and here the negative side is connected with pin number 7. Sorry, pin number 7. Sorry, this is pin number 4 and this is pin number 7. This is pin number 7 is connected with positive power supply, and this is pin number 4 is connected with negative power supply. Okay, and this is positive has been connected to the ground. Okay, so by this you're getting plus 12 volt or minus 12 volt supply. This is the input waveform from triangular. You can see this is triangular waveform of 500 hertz, 10 volt amplitude I have given. Okay, and this is the triangular input, and this is the square wave output. For the observation table, what do we need? Input signal, this is triangular, output input signal amplitude, input signal frequency, output signal waveform, this is square, this is output signal amplitude you have to calculate, and output signal frequency you have to calculate using oscilloscope. Okay, amplitude calculation all of you remember?
Yes.
Number of division in y-axis into volts
सर वो
per division.
फ्रीक्वेंसी कितना रखना है? 500 हर्ट्ज.
हाँ, तो फ्रीक्वेंसी 500 रखो. ओके, एंड फ्रीक्वेंसी कैसे कैलकुलेट करोगे आउटपुट का? ये सेकंड एक्सपेरिमेंट में किए थे, भूल गए होगे, फिर से मैं थोड़ा बता दे रहा हूँ. सपोज फ्रीक्वेंसी कैलकुलेट करना है तो क्या होगा, यहाँ से इस पॉइंट से अगर मैं स्टार्ट करूंगा, ये वाला होगा एक नेगेटिव साइकिल, ये होगा पॉजिटिव साइकिल. ठीक है, तो ये पूरा कंप्लीट नेगेटिव एंड पॉजिटिव साइकिल का कंप्लीट होगा, ये फुल एक साइकिल हुआ. तो यहां से यहां के बीच में एक्स एक्सिस में कितना डिवीजन कवर्ड हुआ है? ठीक है, 1 2 3 4 5 6 7 8. ओके, 8 into this is your time per division. Okay, using this you can calculate time period, and 1 divided by t will get frequency. Okay, so all of you take the screenshot of this sub connection. Okay, and also note down the value. This is for differentiator. Take the screenshot. Capacitance value is 0.01 microfarad. This resistor is 200 kilo ohm. Okay, this is 12 volt, you know, and input value is 500 hertz. The amplitude I have set to 10 volt and a triangular waveform. Noted?
Sir, what is the capacitance value?
0.01 microfarad. Sorry, 0.1 microfarad. Or at least someone write this in the group. For differentiator, capacitance value is 0.1 microfarad and resistance value is 200 kilo ohm. Okay, and this voltage is 10 volt peak to peak, 500 hertz, triangular waveform. Okay, so you have already done this op-amp experiment last week, so you can do this by your own. Then after doing the circuit, get this calculation part done, and this is the integrator circuit. Okay, this is not same as in the manual. Okay, so slight modification is there. So you can also take the screenshot of this. Okay, here the input of function generator. All of you note it down. For different integrator, input is 1 kilohertz, amplitude peak to peak I have set to 2 volt. Okay, and square wave input. Noted?
Sir, could you please repeat it?
You can see this. You can see the frequency is 1 kilohertz for integrator, huh? And input picked voltage is 2 volt. Okay, square wave input. After that, this resistor value is 10 kilo ohm. This is 100 kilo ohm, and this capacitance value is 0.01 microfarad. So what you do, take a screenshot of this and note down the values. This is input value 1 kilohertz 2 volt peak to peak. This is 12 volt fixed, you know. Okay, this resistor is 10 kilo ohm, and second resistor which is connected in between output and pin number 2 is 100 kilo ohm. Okay, so two resistors connected. First input signal is going to pin number 2 through this first resistor. Okay, 10 kilo ohm resistor. Then another connection is there from pin number 2 to this capacitor. Okay, it is going to pin number 6, and the resistor is parallelly connected to in between pin number 2 to pin number 6. In between, a resistor and capacitor both are connected parallelly. Okay, in between pin number 2 and 6. Pin number 4 is connected with negative input. This is grounded. Okay, and this is pin number 7, connected with pin number 7. Okay, values noted, resistance value noted. Yes or no?
Sir, value of second resistor.
Yes, sir.
This is 100 kilo ohm.
Okay, sir.
And the
Okay, this is 10
capacitance.
kilo ohm, and capacitance is 0.01 microfarad. In the A differentiator, it was 0.1 microfarad only. Okay, so all of you design the circuit. Okay,
Sir, 0.01 or 0.10.
for integrator, this is integrator. This is 0.01 for integrator. Okay, and for
Okay, sir.
differentiator, the capacitor has been used. This one, this is 0.1. Okay. ये और एक काम करो, ये सर्किट डिजाइन करते वक्त इसको मतलब ये ब्रेडबोर्ड को हॉरिजॉन्टली रखो जैसे इस यहाँ पे है. ठीक है, ये थोड़ा ज्यादा डिसेंट दिख रहा है और चेक करने के लिए इजी होगा. ठीक है, ब्रेडबोर्ड को हॉरिजॉन्टली रख लेना.
Yes, sir.
तो कितना टाइम लगेगा कंप्लीट करने में दोनों?
चेक करके दिखाते हैं सर.
330 हुआ है, 350 अराउंड खत्म करो, 55 तक खत्म करो दोनों. ठीक है, तो चेक करेंगे. इसका कोई डाउट होगा पूछना. ठीक है, रघुजी मैडम. मैडम मुझे 10 मिनट आसছে.
इनमें से रेवती मैडम नहीं है लगता है मीट में.
अच्छा ठीक है मैम, मैं थोड़ा मतलब 2 मिनट में आ रहा हूँ.
हाँ मैं हूँ आप जाइए.
Room 745. Room 745.
Present, sir. 748 present.
Share your screen and show what you have done till now.
Yes, sir. Wait a minute, sir. I have to just open my Tinkercad, sir.
You haven't opened Tinkercad yet?
Sir, I have two laptops, na. So I am using for Google Meet once and.
Okay, okay. I will wait. Meanwhile,
No, sir. I have opened
751.
it. I have opened it.
Open.
Yes, sir. 1 minute. So can you see my screen? Can you see my screen?
Yes.
Sir, I have made the first one and I am making the second one, sir.
First one is working.
Yes, I haven't checked, sir, but it's working when I started the simulating.
So click on simulation. No, it's not working. Your power supply of
I,
5
I,
volts.
sir?
Power supply voltage is 5 volt, and your negative power supply you have connected wrong. Then supply voltage set नहीं हुआ ठीक से.
Yes, sir.
Resistance value
सर
को correct.
आपके सर जो दिया था उसी डायग्राम के हिसाब से किया सर.
उसी डायग्राम के हिसाब से किए. वैल्यूज भी मैं बताया था ना.
सर वैल्यूज
5
मैंने
volt.
सर ऐड नहीं किया है, वैल्यूज ऐड करूंगा सर. पहले मैं डायग्राम
अच्छा अच्छा
बनाऊंगा.
अच्छा अच्छा ठीक है हाँ डायग्राम.
वायर उल्टा है तेरा, नेगेटिव पावर सप्लाई का,
हाँ?
नेगेटिव पावर सप्लाई का वो
कौन सा?
रेड रेड वाला उसमें जाएगा 8
पिन
पर।
नंबर 4 वाला कनेक्शन उल्टा हुआ है. पिन नंबर 4
ओके सर, आई विल चेंज इट सर. आई विल चेंज
हाँ.
इट सर. थैंक यू.
ओके. तो बाकी सब कर रहे हो, किसी को कुछ प्रॉब्लम नहीं है अभी तक? ठीक है.
All of you have slept or what? सब लोग सो गए क्या? Students.
बना रहे
हम
हैं
सेकंड वाला बना रहे
नो
हैं।
मैम बना रहे हैं.
सेकेंड वाले की वैल्यूज नहीं समझ आ रही.
सेकंड वाले की वैल्यू सर नहीं बताए हैं.
वैल्यूज बता दे रहा हूँ फिर से, नोट डाउन कर लो. स्क्रीनशॉट ले लिया होता सर्किट का.
यस
यस सर.
सर
जो कैपेसिटर है, इनपुट वैल्यू पहले नोट करो फंक्शन जनरेटर का. 1000 हर्ट्ज और जो इनपुट वोल्टेज है 2 वोल्ट हुआ स्क्वायर वेव. 1000 हर्ट्ज 2 वोल्ट स्क्वायर वेव. ठीक है.
यस सर.
देन और कौन सा वैल्यू? ये पावर सप्लाई का वैल्यू तो पता है. रजिस्टर वैल्यू
सर रजिस्टर जो कैपेसिटर के बगल वाला है वो वाला रजिस्टर.
100 किलो ओम.
ओके सर.
वो कैपेसिटी के साथ पैरेलली कनेक्टेड है और एक 10 किलो ओम. ठीक है.
यस सर.
और 5 मिनट बाकी कंप्लीट करो.
सर
हाँ.
Sir, I have done the differentiator circuit, but actually the power supply is not showing anything.
स्टेरियो स्क्रीन.
Yes, sir, sharing. Sir, is it visible?
Yes. Power supply is not.
Sir, when it's not showing anything.
यस सर, मेरा भी यही डिफरेंशिएटर में यही हो रहा है.
Yes, sir. यही हो रहा है.
You have to adjust the time period. That I don't need to repeat every time. Have you changed? What is the time period on oscilloscope?
0.25 होना चाहिए.
Sir, 0.25.
कुछ भी नहीं आ रहा है.
नहीं सर,
Yes,
दोनों में सर.
रेजिस्टेंस का क्या वैल्यू है?
रेजिस्टेंस का वैल्यू लिखो.
मेरा एक में आया, दोनों में नहीं आया.
रेजिस्टेंस 200 किलो ओम. ये अच्छा. पिन नंबर 3 ग्राउंडेड. पिन नंबर 4 ग्राउंड. हमें पावर सप्लाई वोल्टेज दिखाओ. एक सेकंड रुको थोड़ा. इनपुट. अच्छा, एक एंड से चेक करते हैं. इनपुट दिखाओ पहले. फंक्शन जनरेटर दिखाओ. फंक्शन जनरेटर